Hello everyone. So, today this is going to be the second lesson of physics for our YouTube channel, and specifically today there's going to be two parts. It's just going to be a nice intro to projectile motion, and this is really great because it's covered in a lot of definitely some competitions I know of, and also lots of content such as grade 11 and grade 12. So it's helpful as well. And if you also want to do some extra learning, it's very helpful for people who want to get ahead into the curriculum. And yeah, so let's get started. So with projectile motion, there's a lot of things that come with projectile motion. Since if you've ever thrown like a basketball, or definitely watched something fly in the air, and how come it always follows like a curved path? Because that's called it follows like a parabola, or it's in a projectile motion. And when we see look at the definition here, projectile motion is an object that is launched into the air, and it moves under the influence of gravity only. And specifically, I want to highlight gravity because there's no extra forces if we ignore air resistance from it. And specifically, there's only gravity pulling the object down. For example, if you were to throw a ball, we'll just say off a building, and it goes towards the ground, the only force that is actually applied is you throwing it, which is considered constant, and also you also your also gravity as well, since there has to be a downward motion. Now, this doesn't just have to happen with throwing something. It can also be kicking your soccer ball, since there's that nice parabola and kicking motion, since it can also happen on an angle. Now, when we look at one of the most important ideas in projectile motion, is that motion happens in two directions at the same time. So when we take a look at this, when we look at projectile motion specifically, hold on. So when we look at projectile motion, let's just say there is a ball right here. Let's just say pretend this is your object right here. If this was to go up like this and down, there's only two directions happening at the same time, because when we think about it, the one is going vertically, which is downwards, and depending on how high or how low it was, there is also some upward motion in the beginning. However, since it's also since you're also throwing it like this downwards, there's also going to be some sort of horizontal axis as well. Gravity only acts downwards, and this is basically seen as the object is moving at a constant speed, constantly moving. It's moving forward at a steady speed, while also accelerating downwards as well. And that's why it creates this curved path, and eventually it can lead to the ground. Now, when we look at the projectile motion equations, we can see here that when it comes to the x-axis, so this is specifically for only the x-axis. The x is considered for how far you go, and time is just basically time. And that's basically it, because for the x-axis, like we talked about, it's constant when air resistance is negligible. When we look at the free fall y-axis, as we can see, there's many different types of equations. that you can use. One of the most famous ones that is very popular, or it's a lot of people use it, is this one right here, because this G is it can be positive or negative. It doesn't have to be anything. However, if you assume that your initial is going to be, like, for example, because your initial y is based on how high you go in the beginning, and then you have time, and then you have gravity. So whatever, gravity can be positive or it can be negative, depending on what you want to solve and figure out. Now, when we look at a real world example, this is a picture I chose off. Now imagine you're throwing this baseball, for example. So as we can see in this first image right here, there is a person and it's throwing it horizontally this way, and we can see that if this person just threw it threw this ball further than just, let's just say right here, it would go to here, because if you throw it harder, it would go further. However, if you throw it higher on an angle instead of down here, this would stay actually in the air longer. So your T would actually increase. Your T would be, hold on, let me write that down. Your T would be higher on this side, and then T, we'll just say your T is equal to 0, for example. But T would be greater than 0 on this side, because you're throwing it on an angle. Now, one of the main things, even though that there is this example and this example, with this and this example, they have time is, sorry, hold on. Their time, but no matter what, gravity is always going to be pulling them down at around 9.8 meters per second squared. And it's because that's the only downward force that's actually being pulled. And it's always going to be the same, 9.8 meters per second. Now, and when it comes to, like this specific example, we already know that this is going to have a higher T. This one's going to have, this one's going to move further. So the X would actually be longer on this end, but this Y, but the T would be higher on this end. So technically speaking, horizontally would always stay constant if we are if air resistance is negligible. However, also on this side, on the right side, when we're throwing upwards, there's also it would stay higher, but it wouldn't go as much further. And that's going to be the end of this first part.